So let's look at solving systems of equations. First, let's talk about solving a system by substitution. And to solve by substitution, you're going to pick one of the equations and solve it for either variable. So I always like to look for a variable with no coefficient because that's the most likely way to avoid having any fractions. So in our top equation, equation 1, we have y with a coefficient of 1, so that's the one we're going to try to solve for. So to solve for y in equation 1, we're going to subtract 2x from both sides, so we get y equals negative 2x plus 1. Then what you're going to do is you're going to take whatever y equals, and in the other equation, you're going to start writing it out, but as soon as you get to a y, rather than writing y, you're going to put some parentheses. And inside those parentheses, you're going to put whatever y equals, or the variable that you solve for. Now this is just a single variable equation. So we'll solve using our order of operations. We'll distribute, combine like terms, and solve. So distribute the 4, negative 8x plus 4, and keep the other stuff. 3x minus 8x is negative 5x. We can subtract 4 to the other side. So we get negative 5x equals 10. Divide by negative 5. And we get x equals negative 2. So that's half of our solution. Now we just need to know what, if x is negative 2, what does y equal? So you take x equals negative 2 and plug it into the original equation that we solved. So we get y equals negative 2 times x. Instead of x, we're going to put parentheses and fill the parentheses with what it equals. Plus 1. And order of operations to solve, negative 2 times negative 2 is 4. Plus 1. We get y equals 5. So negative 2, x equals negative 2, y equals 5. Negative 2 comma 5 is the solution to our system. The solution is just, since these are lines, it's the intersection of those lines. The solution for any system is just the intersection of those equations. Next, let's look at elimination. When you're solving a system by elimination, you want everything lined up, the x's, the y's, your equal signs, and the numbers. And you want one of the variables, either the x's or the y's, to have opposite coefficients. So like a positive 2 and a negative 2. If they weren't opposite coefficients, you would multiply the equation by something to make them the opposite coefficients. So for example, if you wanted to cancel out the x's instead, we'd be able to multiply equation 2 by negative 3, so that way we'd get negative 3 times 1x would be negative 3x, which is the opposite of positive 3x. So since the y's are already set up, let's just go ahead and combine those to eliminate the y's. So we just need to add. That's what I mean by combine. 3x plus x is 4x. 2y and negative 2y cancels out. 14 plus 2 is 16. So we have 4x equals 16. Divide by 4. We get x equals 4. And similar to substitution, once you have one of the variables solved, plug it in and solve for the other one. So we have x equals 4, so let's replace x with 4. Minus 2y equals 2. In this case, the parentheses don't really mean anything, but it's good practice just to put them. So now we can subtract 4 from both sides. Negative 2y equals negative 2. Divide both sides by negative 2, we get y equals 1. So our solution to this system, x is 4, y is 1, 4, comma 1 is their intersection. It's a solution. So another way that you can solve a system of equations is by graphing. You can either graph by hand or using a graphing calculator. I'm going to show you how to use a graphing calculator, especially for this problem with all these decimals. So the first thing you need to do is go to the y equals, so you can input your functions. But in order to enter a function into a graphing calculator, you have to solve for y. So to solve for y, we need to move the x term over. So we'll have negative 2.13y equals, move the x over, so it'll be negative 1.35x minus 2.36. And we're going to divide everything by this 2.13. Divide by negative 2.13. You don't need to do any simplification here. You just need to put it into the calculator. So first, input the numerator inside parentheses. So negative 1.35 x minus 2.36, and close parentheses because we're done with the numerator, divided by for our fraction bar, and then parentheses for our denominator, negative 2.13. So now if we push the graph button, it would graph our first equation. But let's wait until we solve our second equation. So first move the x over, so 0.32y equals negative 2.16 x plus 1.06, and then divide everything by 0.32. We can input that to our calculator. For y2, parentheses for the numerator, negative 2.16x plus 1.06, close parentheses because we're done with the numerator, divided by parentheses for our denominator, 0.32. And before we push the graph button, it's a good idea to check your window. So the easiest way to fix a window, even if without knowing if anything's wrong, is just push the zoom button, and then zoom standard will give you a standard 10 by 10 window. So if you just push 6, it'll automatically change it and graph for you. So there's the first graph, the first line that we solved in green, and the second line that we solved in blue. Now to find their intersection, there's a few things you could do. You could go zoom, and you could zoom in on that point and try to guess. Keep zooming in until you get as close as you can. But even easier than that is to push this button here, second to get calc. We're going to calculate. And we want to find the intersection. We're going to calculate the intersection. So that's option 5. You can either scroll down or just push 5. So when it says first curve, that's just saying, that's the general way of saying the first y equals that we entered. So make sure you select both. So first we're going to do this one with the positive slope. That's the one that we're on. You can notice that you can figure out which one you're on by moving left and right and seeing which line you're tracing. So there's our first curve. Second curve. By moving to the right, we can see that our little cursor is moving along the other line. So go ahead and push enter. And then guess just means that you want to move the cursor as close as you can to where they intersect. And it'll just speed it up a little bit. It won't take as long to calculate. So here it gives us the intersection is 0.2985. So we'll say 0.299. And 1.3. We'll say 0.3, 0.299. We can round to 0.3 and 1.3. And there's our approximation. So when you have a system of equations with two variables, x and y usually, there's three options. It can either have one solution, which would look like this, the lines intersect. It can have no solutions, where the lines don't cross at all, they're parallel. Another word for no solution is inconsistent. No solution, inconsistent. Or the third option is that the system has infinitely many solutions, in which case we'll say that it's a dependent system. And what that means is the lines overlap. So here in colors, red and blue mix and give purple because they're overlapping, they're on top of each other. It's the same line. So that means every point is an intersection. So there's infinitely many solutions.